This episode is sponsored by Kendo UI. Kendo UI allows you to build better apps faster. They have a comprehensive library ranging from data grids and charts to buttons and sliders. Plus, you can use their components as plain JavaScript as well as in Angular, React, and Vue. They have a large collection of customizable popular themes like Bootstrap and Material. Go check them out at javascriptjabber.com/Kendo UI. Hey everybody, and welcome to another episode of JavaScript Jabber. This week on our panel we have AJ O'Neill.
Yo, coming at you live from BYU campus in Provo.
Aimee Knight.
Hello from Nashville, Tennessee.
I'm Charles Max Wood from devchat.tv. And this week we have a special guest, and that is Valeri Karpov.
Hi, coming to you live from Miami, Florida.
So you've been on the show before. It was quite a while ago, and I think you came on and talked to us about ES 2015 generators, if I remember right.
Yeah. I've been on JavaScript Jabber twice, if memory serves. Once in 2013 when I was talking about the main stack, and I think 2016 I was talking about generators back when ES6 was brand new.
Yeah. That's right. We had you and Ward Bell on talking about the mean stack.
Oh, yeah, I remember that. That was a good show.
Ward's always a good show. Yeah, why don't you just remind everybody who you are, since it's been a couple of years since you've been on the show.
Oh, yeah. Well, a lot of things have changed since the last time I was on the show anyway. So my name is Val. I'm the lead backend engineer for a tech startup out in the Bay Area called Booster Fuels. We deliver gas to people's cars in parking lots. Pretty cool stuff. We do everything in Node.js and MongoDB. On the side, I also blog at thecodebarbarian.com, and I'm the lead maintainer of Mongoose, which is the most popular ODM for Node.js and MongoDB. And I'm also now on the Mocha core team, the test runner. So that's kind of a general summary of what I do. And recently, I just came out with a new ebook on async await that I'll link to later.
Holy cow, do you sleep?
Oh, man. No, I'd try. You're the one that pulled the all-nighter last night. I slept like a baby.
Yeah. I did pull an all-nighter last night. But let's don't talk about that. So it looks like you've been dealing with this sort of asynchronous or, promises, generators, all that stuff for a while. It seems like there's a lot there. We talked about generators last time. We're talking about async await and promises this time. Why is this such a big deal? I mean, it seems like most people just either reach for promises or async await, which, if I've understood it correctly, is more or less just a wrapper around promises, is a little cleaner and easier to reason about.
Yeah.
So do people need to understand this stuff deeply, or can they just go find some example on Google?
Yeah, that's my question too. How did you make a book out of this subject? I mean, this is, I didn't think this was so deep. So I'm really interested to hear.
Oh, there's a lot of patterns and there's a lot of kind of macro going to micro where you need to understand promises, and then you also need to understand how async await interacts with promises. Now, examples kind of get you most of the way there. You can cobble together stuff off of Stack Overflow, but getting yourself kind of like an integrated understanding of issues, kind of like error handling. Error handling is one of the big advantages of async await in my book.
That makes sense. Let's start with kind of a definition or an introduction to it, though, and talk about what async await is and how it works. Yeah,
sure. So first, when I first started developing Node back in 2012 or so, everything was callback based, right? You execute an async operation, you pass in a callback that takes an error parameter and a result parameter, right? No one really liked that. That tended to cause a lot of issues, both in terms of readability and in terms of errors. So there were three different ways that you can kind of throw an error in Node.js. You could throw a synchronous error, you can report an error to the callback, and then your callback function might throw an error, so someone needs to catch that too. So that made it very easy to have like an exception slip through the cracks and crash your entire server. So then we moved on to promises. So promises and promise chaining. Promises do a good job of like consolidating errors in terms of like synchronous and asynchronous errors propagate down to .catch. But promise chaining isn't quite enough because it becomes hard to do things like if statements, for loops. Those things, you really miss them when you're doing promises. So that's when generators came out, actually in the same general. Promises were also ES6 or ES 2015 as well as generators. But promises have been around for a while before that because promises were something that you could implement purely in user land, whereas generators, you needed to actually lean on the JavaScript runtime. So then libraries like Co came out and made it so that you could use promises, but also use for loops, try catch, if statements, and all of the kind of language constructs that you're used to in synchronous programming, but still have an async, but still write async code. And then async await came out, which removed the need to have an outside library in order to write kind of for loops with promises. And then also async await adds things like cleaner stack traces, and it relies on the JavaScript runtime. So you don't really have to rely on an outside library to kind of handle your promises for you.
I'd kind of like to touch on that specifically, if we are okay. So I read an article a couple weeks ago about the difference between the stack traces for promises and then async await. And I didn't realize, so according to this article, the way promises work is they have to pass the stack trace around. And so with async await, you don't need to do that. You can just retrace the stack trace by getting a pointer to it. Can you kind of speak to that and why people would want to use async await because of that?
That's actually a pattern that I'm not very familiar with, so I'm going to have to pass on that one. What I was talking about with cleaner stack traces is that if you're using a library like Co, you get a lot of kind of internal Co code in your stack traces. You get some Co functions like gen.next, all of these things. Those tend to clutter up stack traces, whereas with async await, when you await on a promise, that goes into JavaScript runtime, so it doesn't really show up in your stack trace.
Okay, I'll post a link for listeners if they want to check out this article that I was referring to, because I know for me sometimes, believe it or not, I could be a little bit like AJ, and I'm like, well, I like the readability of async await, but what am I really gaining anything from it, like performance wise, or really just anything like that the user might potentially see versus just my eyes? And reading this helped me realize that it's not just better from like my usability standpoint, it'll be better like from a development standpoint and also performance wise.
Yeah. I guess going back to the question of whether async await has some advantage over promises or not, it really depends on what you're using it for. So if you have a very simple application that doesn't really need to do conditional requests or looping or anything like that, you're just sending out one HTTP request to load a page and then rendering a React view, async await isn't really going to help you very much. But one thing that I've been kind of curious to tinker with is using async await as kind of a replacement for, say, Redux Thunk or Redux Saga, and just kind of using vanilla async await as a tool for just dispatching actions asynchronously from a function.
So to the point that you mentioned earlier, like the way that you approach the code, how you're handling branching and that sort of thing, I think this is one of those areas where JavaScript has rarely, if ever, been treated idiomatically. It seems to me that people are always trying to find a way to solve problems that exist in other languages in the way that they're solved in other languages, rather than the way that they're solved in JavaScript. I mean, do you find any value in the design pattern that emerges out of using promises where you are calling functions rather than branching line after line with if-then statements? Or do you feel that like being able to twist it into a line-by-line way of programming is just empirically or spiritually or whatever better than the way of quasi-functional programming, if you will, that promises lend themselves to?
Well, I guess the question is what makes async await not functional? Because it's based primarily on functions, right? You mark a function as async, and then that function always returns a promise, right?
Well, I'm not saying that it's not functional. I'm just saying that there's a certain pattern of programming that emerges when you are doing promises that it seems like lots of people want to avoid, because they want things like async await and they want it to look like Python and behave like Python. And I don't know if it's necessarily better that way. Like if there's something that's better about that style versus the just call one thing after the next style. Like, why is it that people are trying to avoid this in the first place? I guess that should be the real question. Like, what is wrong with promises that people want to avoid them? Or what's wrong with async that people don't like it?
So let's talk about what's wrong with primarily with promise chaining. By async, you mean like npm.js/package/async, that one?
No. By async, I meant asynchronous programming, event-driven programming, as opposed to procedural programming.
I don't think there's really anything wrong with event-driven programming, but I think you need a little bit of both, right? If you need to do multiple kind of asynchronous operations in sequence in response to an event, that makes sense for async await. Whereas listening to something like listening to an event emitter in async await, you can do it. I have some blog posts about it, but it doesn't really give you too much. It actually kind of starts looking like Python, where you just have a while true loop where you're pulling stuff off. So that's a little weird. But I think having both and the optionality to do both is very powerful, because there are places where we're having async await makes a lot of sense, where your code like wants to be procedural. Whereas there are definitely other places where, responding to an event emitter where you want kind of a more event-driven approach, right?
So describe something where you think the procedural approach is just better. Because I agree with networking. I think that networking, the event-driven approach, to me, like contrasting my experience in my younger years using, Ruby and then Python and then C and then Node was so much easier to comprehend networking events. But I think you're right that there are some things where if you are trying to, if you're using the event pattern, it's not as good as the procedural pattern, like logically. And I want to hear what your examples.
Again, implementing complex business logic sounds like a bit of a buzzword, so let me just give a more concrete example. So at Booster, we have our backend APIs written in Node. We use Co and Yield for now because we still haven't upgraded to Node 8. Been a bit of a challenge there. But we will eventually switch to async await, and Co Yield is pretty much the same thing anyway, so we're not in a huge rush to do it. But so say we have a function to create a request that's essentially an async function, right? That function needs to, since we use MongoDB, that function needs to write to a bunch of different collections. Needs to create the request, needs to increment the user's number of requests count, needs, if certain feature flags are on, it needs to write to certain collections as well. Maybe it does some analytics work. All of this kind of needs to come together into one function that we can call in response to an incoming HTTP request, right? And we need to be able to easily say, what does it mean for like create request to fail? And what do we do when create request fails? We need to have like this one unit that is like create request that does a bunch of stuff. And if you don't have that, if you have that using conventional event-driven programming where you have callbacks on callbacks, error handling becomes trickier, becomes harder to read, and it becomes harder for someone who's putting on their procedural programming hat that says like, okay, I need to, if this feature flag is on, we need to do this. If that feature flag is on, we need to do that. We need to write to the database here. If that fails, we don't want to treat that as a fatal error. Things like that, we don't. Things like that, async await is going to be much better for.
Yeah, I think one thing that comes to my mind is handling logic around authentication and permissions. I would say that probably seems a lot more coherent to the understanding when it's procedural as opposed to when it's you've got event-based stuff mixed in there. But I've also had cases where event-oriented is really actually helped, like particularly there's something I was doing where there was login, and then there was like checking a credit card, and then there was making a purchase, and there was like multiple cases where it would need to like jump back to, like, if it hit an error case here, it'd have to go back. I don't remember well enough to describe it, but it was something where intuitively I might have thought that procedural would work well, but then it turned out that having it event oriented really made it easier in the end.
What about like if you're implementing retry logic? Because that inherently is can be pretty gnarly.
And that's
actually exercise too in my on the first chapter of my ebook is implementing retries when fetch is unreliable.
And so you're using async await. You would recommend using async await for that. Is that kind of what you're thinking too, AJ?
Well, in the case that I was just talking about, had to retry the credit card number if it was wrong or something like that, and had to basically call the prior function and then continue down the stack again from the case where it could handle that particular error. In that, I really liked the event-driven approach. I don't think that I'd actually want to try to make it procedural. I don't know that there'd be much benefit to that because it's event-driven in the terms of users,
Yeah.
Users are making a choice that you can't predict when that choice is going to happen. So it's different from database logic. You can predict the database is going to respond immediately with a defined set of data that you expected.
You'd hope. Yeah. I would agree with that. I mean, I kind of wonder though, if we're writing JavaScript, I mean, that's kind of evented. That it was built to be evented, no?
Well, yes and no. It was kind of, there was a lot of compromises made to make it look familiar and desirable to other developers.
Yeah.
So, promises should have been a primitive when it was designed, or some sort of event handling, but it was kind of a hodgepodge of half wanting to be an event language and half wanting to look like Java.
Well, anything is better than callbacks.
Yeah, I had a lot of trouble with callbacks back in the day.
Retry logic with callbacks. It just sounded like shit.
Oh, yeah. Yeah, even with promises, it's pretty subtle because you need recursion. And, recursion is doable, but it's more complicated than it should be. And if I want to do retry logic, I want that to be 3 lines of code. I don't want that to be, I need to do a recursive call and try to explain to people what recursion does.
Here's my, I think age showing a little bit in the industry now that I can't really call myself a junior anymore, but there's a part of me who thinks, if people are just using async await, maybe it's abstracting away so much that they don't necessarily have a good grasp of asynchronous flow. Do you think that's a problem, or do you think that's even something that could be the case?
To be honest, I think it's more of a benefit than anything else. One of the things that we've seen that works really well with async await at Booster or with Co and Yield is that it's very familiar to people that don't know anything about JavaScript. Our iOS dev has contributed to our Node.js stack, and as far as I know, he never wrote any JavaScript before coming in. But at the same time, all he really needs to do is okay, you need to throw in an await every once in a while or a yield every once in a while, and everything pretty much works as you expect, which is nice. It certainly would be easier than if we had built something in Cycle.js with observables and crazy one-way data flow. Would have been really hard to get him to wrap his head around that. So yeah, going back to your example, AJ, about login, actually, I was just using async await to write some GitHub OAuth flow for just a project that I'm tinkering with, and that was actually another good case of where async await really helps. Is you have multiple steps in the OAuth flow, where the final step in the web application OAuth flow, you need to actually make an HTTP request out to GitHub to verify your access token and then persist that access token to your database. So you could do that with promise chaining, but it's often easier to just do it with async await because it looks more procedural. It's easier to grasp.
Yeah. So what are the core tenets of your book? Like what's the flow that you're leading the reader through?
Sure. So book is broken down into 4 chapters. The first one is entitled, I believe it's Async Await the Good Parts. That one kind of just walks you through basic design patterns and introduces you to what are the things you can do with async await. Some of that is, for loops, try catch, handling retries is one of the exercises. That's a fun one. Chapter 2 is entitled Promises from Scratch. So in order to use async await properly and in order to really understand how async await works, you need to actually understand how promises work as well. Because diving deep, because kind of how async await works is when you await on a promise, the JavaScript runtime basically calls promise.then with its own onFulfilled and onRejected. And when the promise fulfills, async await converts that into an expression and when the promise fulfills, JavaScript converts that into something that you can assign to a variable. And if the promise rejects, then JavaScript converts that into a conventional error that's thrown that you can wrap and try catch, right? So that's chapter 2, all about building promises from scratch and really understanding at a deep level how promises work. Chapter 3 is entitled, I don't exactly remember what chapter 3 is entitled, but the general idea is it's about getting a deeper understanding of how async await works with promises by taking your custom promise library and instrumenting it. So you can kind of see you can kind of tease out what the JavaScript interpreter is doing under the hood. And then chapter 4 is async await in the wild. So that one includes kind of a general framework for deciding whether a given library or framework on NPM works with async await, and kind of defines for you what it means to work with async await, and then walks through various examples of does async await work with the MongoDB driver? Does async await work with React? Does async await work with Redux? Does async await work with Express? And those are the 4 chapters.
Okay. So as you're speaking, one thing that comes to my mind is, so JavaScript is multi-threaded, but it's not multi-threaded in a way that the developer, the programmer, often interacts with the threads. I think web workers is the only area where you can interact with threads, and it's completely memory safe. Memory's copied. There's no references. So it's essentially you're running 2 different programs, and you've more or less, you just have IPC that's baked into the language. So people are kept safe from threading, but both in the classic JavaScript function style and in promise style, it becomes apparent that time is passing where the program is doing something else, and when it comes back to you, variables are changing because you can have multiple events can have fired before the event that you are currently looking at lexicographically in your code gets its callback. And so variables can change at different times. And that is sometimes unexpected. I think that's, from what I gather, that's the number one confusion that people experience when they begin using JavaScript when they come from some other language, or even if they're just starting out with JavaScript as their first language. Does async await have any effect on that type of on the way that you program, or does it make anything more confusing or less confusing in terms of those background changes? Or I don't even know exactly what to call that problem.
Yeah, it's definitely a challenging problem. For example, if you're working with Redux, global state might change in between 2 events, even though you think those 2 events are kind of sequential. Another example on the back end is, your database changed underneath while one request was in flight, but then another request came in. And to be honest, as far as I know, async await by itself doesn't really have any way to help with this. kind of the problem of, okay, data changes in the background. Mostly because async await, it's still asynchronous under the hood. Just, when you await on a promise, the async function that's running in becomes paused. So that means, execution is suspended and it will start back up later, right? On a different tick of the event loop.
So intuitively, I haven't really used async await. But when I think about, one thing that I like about my programs as they are is that my procedural code, I know that kind of thing won't happen because it's procedural code. And I know that things aren't going to change on me in procedural code. But async await allows you to write procedural code where things can change. So do you, is that a hard hurdle to get over mentally, to readjust to that?
On my end, it really isn't. But the reasoning behind that is when you're working on the server side, there's really no guarantee because most servers are going to run in, or at least most servers these days, like your average REST API, you're going to have multiple instances running in parallel anyway. So if something is even still it's single threaded, you're still going to have multiple instances of it running. And who runs a single threaded web server anymore?
So, you're saying, if I was writing a web server in Python, I would still have these same issues related to the database changing from underneath me, but from line 5 to line 7, because, there's another instance of this Python thing running, and so that could already happen anyway.
Sure. And for what I understand, Python web servers often do a lot of event loops on occasion as well. There's libraries like Tornado out there for Python that basically give you, an event-driven web server, kind of like what you would get in Node, but in Python, because event loops are awesome, right?
Unless they stop unexpectedly. I opened a new issue in Node last week.
Oh my God.
Oh, story time.
Another time. Or after the show, I'll tell you.
Okay. I was going to ask a question. So and excuse me if you guys were talking about this because I was having to answer somebody on Slack, but do you think there are cases in my code base where I would want to use promises in cases? This is kind of what we were talking about, but if it's not from a user's perspective, but actually from when I say user, from we were talking about what our preferences are versus procedural versus evented. So not the preferences, but actual performance or anything like that. Are there cases where I would want both in my code base, or would I want to try to be consistent across the board?
In terms of performance, I haven't actually profiled async await against promises by themselves, or have I?
And I guess I would have to say, if we're comparing, I'm not comparing transpiled versus, native or something like that. I'm talking about native versus async.
Versus using a promise chain?
No. Well, is async await actually supported in any browsers yet? I don't know this.
In most recent versions of Chrome, yes.
Okay.
That's the only thing that I work with, so I don't really know otherwise.
Okay, so that's what I would be comparing it against.
So you mean comparing, say, async await versus just a function that returns a promise in Chrome?
Yes.
Haven't run it yet. That's a good idea. I'll keep that in mind for a future episode.
Okay. Well, then, so if we're not even talking about performance, just other than my own personal preference, because my personal preference is consistency. So tell me why I would not want to be consistent in my code base and use one thing or the other.
So where would you be inconsistent?
I'm asking, would I want to, in some places, use promises and in some places use async await? And if so, what would those places be?
Oh. So with async await, you do need to use promises as well. So async await kind of builds on promises, where it's a syntactic sugar that helps you with constructing promises. But in the end, when you're calling an async function, you get back a promise that's indistinguishable from what you do with the promise chain.
Yes.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open sourced Sentry if you want to self-host it. Use the code DevChat at Sentry.io to get 2 months free on Sentry's small plan. That's code DevChat at Sentry.io.
So from what I was hearing with our earlier discussion, it sounds like if you're doing something that's event-driven, then promises are a natural fit. So something like you're waiting on user interaction, you're waiting on network interaction, like there's an undefined time of events that are based on external sources. And if you're doing something that's part of a closed process that's meant to be encapsulated, like authentication, permissions, a classical object that is save, rehydrate with a database, those cases where async await would shine because it helps keep that as an encapsulated procedure.
It's interesting. I wouldn't think of user input or like an inbound network event as something that would naturally fit into a promise. I would think that that's something more for like an event emitter or just like event handling paradigm, like the HTTP server and Node, just like http.onRec.
Okay. Well, yeah. So I'm thinking emitters / callbacks / promises. But no, that makes Amy's question actually more specific, and now I'm thinking on that more specifically as well.
Yeah, that's fair. And if you can have, respond to network events in a perfectly synchronous way, or respond to user inputs in a perfectly synchronous way, then yeah, you can and probably should. But what async await gives you is just like one consolidated function for responding to a network event or to some sort of user input. Like user presses a button, I can send out 4 HTTP requests and have that all encapsulated in one promise for me.
So I guess where would you not want to use it? And the thing that comes immediately to my mind is I would not want to use async await with network events, because then I'd be programming like I do in Python, and that to me mentally doesn't make as much sense. It's not something that I would enjoy as much or feel like it encapsulate what's actually happening as much.
That's fair.
So what is?
I don't think you would use async await for conventional conventional web server programming where you have a while loop and you're pulling events off of an HTTP server or whatever, an HTTP request queue. That's not something that I recommend doing. You can do it, but I don't think it's necessary.
So
for defining a handler for a HTTP request, I think async await makes a lot of sense.
Okay. So queue, you would say no. That's what I understood correctly. Like you don't think that's a good fit?
No, I think that syntax, that belongs in Python or Go. I don't think that's a good fit for JavaScript. But I think for separating out like the framework, that's HTTP, Express, whatever, versus having an async function that does some business logic. I think of those as kind of two separate things. And for the event-driven side, definitely the framework side is great. Async await, I find that to be the better paradigm to use for business logic.
Okay, I think that's a good definition. Did that answer your question, Amy?
Yeah, that helped bring a lot of clarification.
So the thing that I'm trying to visualize And I have to apologize because I've tried to ask this question like 3 times and I've been muted. And so somebody else would chime in and I'm like, what the heck? Anyway, it's totally my fault. So anyway, what I'm curious about is you mentioned that the async in front of a function makes it return a promise. But what is the await part of it? Because you can put multiple awaits in there. Is that saying that it resolves the promise for each of those awaits, or do those all kind of become one event? I'm trying to figure that part out.
No, it becomes one promise in the end. So when you have a function that's async, it returns a promise.
Right.
When you await within that, function, that kind of pauses execution of that function and goes into the JavaScript runtime back into the event loop to process whatever else is on the event loop, right? And then the function will resume later once the promise is settled. It's kind of like if you've worked with generators before, you know how a generator, when you yield, that actually kind of exits the function, but then saves the function state so it can pick up where it left off when you call next. And actually, if you actually look into how Babel transpiles async await, it actually transpiles it down into generators.
Oh, interesting.
That is interesting because it's compiling from an advanced form of JavaScript to another advanced form of JavaScript. So if the target is a more generic JavaScript compiler, does it have to recompile it again?
Yeah. If you need to go from generators down to ES5, then you use there's a library called Regenerator out there that's like Facebook's ultra sophisticated tool for transpiling generators into normal functions, which is a task that I tried to replicate once and failed horribly. It is a very complex thing to do in general. Just to get it to work for just basic generators already took me like half a day, and I just gave up, decided Facebook could do it for me.
So this is one thing that really confuses me, and I'm not sure if my assumptions are correct or not, but back in the day, like people used to be really, really concerned about JavaScript performance, even with Chrome. And my understanding is that the way that these transpilers have to work really weird things to get something that's not syntactically part of the language to become part of the language actually is really intensive and makes the code size much larger and run slower. So, I mean, like, if you haven't solved user experience, you haven't solved anything at all. So if developer experience is important and this provides really great developer experience, then most likely the slowdown in the code size bloat is worth it because you're being more productive and you're getting more done. And if you get more done, you'll get more customers and blah, 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 and so on and so forth. But I think it's really weird when people talk about how complicated their experience in trying to like replicate these features that aren't like natively part of the core JavaScript language is, and that in just a few years, like the emphasis went on performance to being on like, I guess, developer experience or what's driving these changes.
I think much of the point is that these features are now part of the core JavaScript language. Like async await is every bit as part of JavaScript as arrays are right now. It won't work on IE8, which is why you need a transpiler if you want to support IE8.
Well, and I mean, I think there's definitely other environments where that are probably less traditional, so they don't matter as much. Like all of the embedded interpreters that go into like games and like that are integrated into C language stuff, like Duck. Was it called Duck.js? Is that the one? And like,
I don't know that one. That's cool.
But there's like, because JavaScript's been around a long time and it's been integrated in a lot of different systems. The most popular are the browser and Node, but there's other stuff out there too, and that are, they have specific requirements that they're trying to get met that are niche, and so I think there's a lot of, if you wanted something to run in those, which most people don't, I don't think that something like, if I have to Google it to know if it's the real name. I think it's called Duck.js, but I don't think that it will ever evolve to include generators or something like that, because it's meant to be an embedded JavaScript environment.
Yeah, I guess another example is the MongoDB shell, which currently doesn't support generators either. But that's also kind of a wildly different JavaScript runtime than Node or the browser.
I'm guessing CouchDB probably has something similar as well.
Yeah, totally fair. But on the other hand, I've been working with MongoDB for 5 years, and I've never actually written something that I wanted to run in both the shell and Node. I once tinkered with building a something that's compatible with the MongoDB shell, but in Node. But on the other hand, I kind of gave up on it because I couldn't find a good use case for it. It just seemed like an interesting mental exercise with no practical application.
And there's some other ones too, like like the Wii and the Wii U and stuff like that, but they're missing other things that are vital that make them probably not worth trying to support, because the kind of things that you'd want to do, like they're missing like video codec support that you would reasonably want to use, and that sort of thing.
Yeah, exactly. I guess another fun environment. Have any of you guys worked with what do you call it? With EngineScript, Nginx's like JavaScript equivalent thing?
I did not even hear of it until just now.
I hadn't either. That sounds kind of cool.
I haven't either.
Oh man. Well, EngineScript has their own, or Nginx has kind of like their own internal JavaScript environment that you can write stuff to configure Nginx from like a JavaScript dialect. But on the other hand, like it doesn't support a lot of things, and it supports like multi-threading, I think, or it actually supports multi-threading, which means like it doesn't strike me as actually being JavaScript. It just strikes me as like a dialect that is generally similar to JavaScript, but not exactly JavaScript.
Like Windows Scripting Host?
I don't know what that is, so.
It's just another server side. It's been around since like Windows 95 or something. Well, I don't think they had made the partnership with Sun yet. Maybe Windows 98, but it's trying to remember the other one that was popular right before Node. There was like a couple other environments that were fairly popular, but this one was synchronous. So if you want to do a file read, you can do a file read in Windows Scripting Host, but it's synchronous.
Okay. Kind of like Node's read file sync.
Yeah. So Windows Scripting Host was built. Oh, and also Texas Instruments had I think it was called Rhino.
Oh yeah, I used Rhino back in like 2008. That was fun. I used it for actually parsing JavaScript though, not actually running it.
Yeah, they had their entire embedded build system for their OMAP processors, which are similar to what go in the phones, was built in this weird version of JavaScript that, like, I realized it was JavaScript eventually, but at first I didn't. And like all the globals from the different files all get hoisted. And so you'd have issues where it's like, where the heck did this variable come from? And like anytime you included something, it just became part of its parent script. It was challenging to work with.
Yeah. Going back to the web performance question, I would say that keeping bundle size small is very important. I don't really know too much about that though. I haven't really worked with Webpack as much as I would like. On the Node side, I don't really worry too much about like the performance impact of async await versus promises versus proxies versus object.define property or any of these other things, just because like I've profiled my APIs and they pretty much spend 99% of their time waiting on the database anyway. And even then they're not very slow. So like the performance impact in that point is just minimal. I'm like, if I switch to using promise chaining, maybe I could shave off like 0.001% on my average API call, but that doesn't really move the needle for me.
Yeah.
I was going to say, I think I point that out because sometimes it's hard to get business behind, allowing you potentially time to do this. And if you can't get business behind on it, then you'll probably end up doing it kind of in your own time. So it's helpful to be able to show them actual statistics of why migrating over to something or spending time onboarding a team onto a new technology is valuable.
Yeah, and there's very few cases where the number of function calls you're doing is going to make an impact. Like in Node, in the event emitter, they do some weird crap if you look at the source code for the event emitter. But in that specific case, because it's something that's used so incredibly often across so many different modules, it actually does make a measurable performance impact that is significant to the people that are using it. But most of the time, the extra overhead of 2 function calls for your promise or whatever aren't a big deal. And eventually that'll probably get optimized away in the engine like Nitro or Chakra or V8, etc. Yeah,
that's a fair point, actually. I guess like my Node comments were coming from like my app developer hat. Whereas, if I go back to Mongoose and put on like my library developer hat, actually with Mongoose, we pretty much implement everything with callbacks, at least internally. Just everything is exposed with a promise API that you can use promises with it, but we don't really use promises internally. And that's one of those things where unsubstantiated performance benefit, I haven't really run any very rigorous benchmarks on it, but it's been fast enough with callbacks. So I figure if I don't rock the boat too much, it's not going to screw everything up.
Yeah, and since it's mainly interacting with a database and most of the time is waiting, again, what else were you going to do with those CPU cycles?
Well, I mean, the last thing you want is for your app server to be like blocking the database or being the bottleneck. But yeah, generally, if you're not doing anything too crazy, that's not going to be the case. But I figure, people do some crazy things with open source libraries. So I figure, be defensive and kind of just assume that the user will try to break everything.
Or that there's enough users that they'll try everything and one of the things will break it.
The infinite monkey theorem. Oh, yeah.
So where do you find that you use async await the most? Like, what's the use case that you're using it the most on?
Again,
is it database stuff or is it something else?
Yeah, right now it's primarily for all of our backend services at Booster, as well as my static site generators and things like that. Example scripts are also a lot cleaner and easier to deal with. Yeah, generating documentation is another good use case, just because I just want to write a script. I don't really care too much about performance there. I just want to write like one imperative script that loops through a bunch of files, writes them. Maybe does an HTTP request here or there.
Right.
So yeah, I've pretty much just been using async await and co for pretty much everything since probably the latter part of 2015, just because it's made everything so much easier.
So are you primarily working on the back end or the front end? It sounds like back end.
Oh yeah, I'm definitely primarily a back end guy.
So
my primary library work is Mongoose backend, just database ODM. And then I'm the lead backend engineer at my day job.
So that would be why you haven't really used Webpack.
Yeah, exactly. And even then, like the front end websites that I maintain are pretty much all static sites with like minimal amount of JavaScript thrown in on the front end. So I don't really do as much on the React side anymore. I do React and NG2 every once in a while, but not as much as I used to.
Cool. Was there anything else we should dive into here before we go to picks?
Let's see here.
I could tell you the story that I mentioned earlier.
Yeah, that would be good to hear about.
So I'll try to keep this brief.
Yeah, I'm gonna get kicked out of here in like 2 minutes.
But also, I think we were supposed to talk about Promise.finally at some point or another. We ended up talking about async await a bunch.
Yeah, why don't we have Aimee throw some picks in, and then we'll do the rest of that, and then we can kind of rearrange the recording to put her picks in with everyone else's.
I'm really sad that I'm gonna miss AJ's story though, because I might stick around for that for a second.
Okay.
You want me to do my pick then?
Yeah, go for it.
Okay, I'll just go really fast. So I'm going to actually just pick this blog post article that I mentioned earlier because I really think people should check it out. I think it is one of the developers who works on Chrome but it is.
I know Matthias. He and I hung out in Uruguay once. He's cool.
Yes, it is. So it's about async stack traces and how they are implemented in promises versus async await. And so if you're anything like me, I really like to kind of deep dive on this stuff and understand things at a little bit lower level. It just helps me kind of grok it. And anyways, so that's it for me.
Awesome. All right, AJ, let's hear your story, and then we'll get to promises finally.
Okay. That was, I don't know if you meant that as a double entendre, but yeah, anyway.
I didn't, but.
So I had this issue on Windows where I had some code that worked, and I'd already kind of run into an issue on Linux with readline because you see these things like for the Ruby installer, for the Rust installer, for like many different programming languages where the language tends to move faster than the package managers do. And like Node doesn't do this. I don't know why, but most of these other languages have like a curl bash installer on their homepage. And I decided to move some stuff over from bash to Node because I'm installing a Node app. And as I did that, it turns out that readline behaves slightly differently when it is being called from bash that's being read as input rather than read as standard in input, which is what curl pipe bash will do, rather than read from file as input. So this is like a weird thing because you'd think like you're reading a stream. It shouldn't matter whether it's a file or whether it's standard in. It should behave the same. But for some reason, there's something weird that goes on. So I found this bug where sometimes Node would hang on Linux, and they gave me some tips to say, oh, well, yeah, in this particular case, this little bug expresses itself and it doesn't happen anywhere else, so it's not been that big of a deal. So I changed it a little bit, and then I ran the same thing on Windows, except that Windows doesn't have curl pipe bash, so this wasn't even that problem at all. But it somehow I managed to get the same bug to express where it would just hang. But instead of like finishing everything and then the process hanging open, where like it basically, everything's run, but you have to hit enter to get it to stop and proceed to the next terminal line, it actually stopped the event loop in Node. So the process of making an opening read line, calling an HTTP request, closing read line, and making another HTTP request, something about that creates this Goldilocks condition on Windows where the event loop halts. And you can test this, like I've got an issue open. You can test this by doing a set timeout and a process.next tick right before, which if the event loop didn't halt and it was something that was wrong in the HTTP library, you would still see the output of the screen saying, it's one loop later, it's 10 milliseconds later, whatever. But it actually stopped and halted. And I spent hours trying to track this down because, again, this is one of those things where I'm thinking, like, there must be something wrong in my code. And it ended up being a bug in Node.
Wow, that's a debugging adventure.
I have these all the freaking time because I just do weird things.
Oh, man. Yeah, no, I have never even thought about trying to use Node for that. So that's pretty cool.
Yeah, well, so what it is that I'm actually building is basically it lets you break out of localhost. The thing is called Telebit, and you can curl bash install it, or you can npm install it. Either way, you can run it on Windows now or Linux or Mac, and you will get kind of a random domain name, and then you can point it to a local port, and so you can then test your thing that you're developing on localhost. You can test it on mobile. You could call up somebody else and have them tested. And most importantly, you can start to build peer applications on localhost because you're not constrained to not having a network environment. So you can actually, begin in a very comfortable environment and not have that constraint of not being able to use things like WebRTC and whatnot. You actually can get incoming traffic to you. So those are the kind of use cases it's for. And I'm building it for the home server, which needs all of those things.
Very cool.
All right. Well, let's transition back over to the topic for today and talk about the promises finally. So what does that do?
So you have try, you have catch, you have finally in Java or most other programming languages. With promises, you only have then and catch, but now we also added promise.finally, which executes, basically regardless of whether the promise was resolved, was fulfilled or rejected. So it will execute whenever the promise settles, and it will propagate that promise. The promise rejection or the promise fulfillment through the dot finally call. Yeah, new language feature in ES 2018. Now it's actually formally part of the language, but it's still not in Node.js 10 as far as I know. I think it's behind a flag or you need a polyfill.
That's good to know. I was going to say, where is it implemented? So yeah, sounds like it's not in Node 10.
Yeah. I think it's either behind a flag. There's definitely a polyfill for it. In the blog post that I wrote about Promise Finally, I mentioned a polyfill for it.
Cool. So this is just a way of ensuring that some cleanup code or some other mechanism for making sure that something that has to execute every time happens, regardless of the.
So a classic use case going back to AJ's example of things changing in the database, like when you don't expect them. What I've been using Finally for is cleaning up distributed locks on our backend. So there are certain operations where this just needs to run in isolation. No other operation should be running that would conflict with this particular operation. So what we do is we grab a distributed lock, and then in the dot finally, we release the lock.
So if people want to learn about all this stuff, we talked briefly about your book and the different sections in the book. Where do people go find the book?
Asyncawait.net. Async await is one word. So there's also a special link for JavaScript Jabber listeners. So asyncawait.net/JSJabber gets you a nice discount.
Gotcha.
And that'll be my picks.
Are people going to be in a specific situation where they're going to really benefit from this? I guess the better way to ask this is, who are the people who are going to benefit the most from a book like this?
If you've worked with promises, if you kind of are getting tired of working with promise chains and finding them to be convoluted, you're getting Redux Saga or Redux Thunk is getting you down. Maybe you should check out Async Await. Or just in general, if you're curious to level up your async programming game and kind of become well versed in this new paradigm and see if it works for you, either or.
Sounds good. Now, if people want to see what you're working on these days, I'm assuming you have a blog or Twitter or GitHub or all of the above. Where is all that stuff?
The above. I can post it for you in the chat or in the Google Doc. But my GitHub handle is vkarpov15. V is the first letter of my first name. Karpov is in my last name, and then 15. Twitter is @code_barbarian. Fun little moniker. And what do you call it? What was the other one? Oh, my blog is thecodebarbarian.com. So you can follow me on any of those, and always have fresh content on my blog, and always working on something open source on GitHub.
Good deal. All right, well, let's go ahead and get to some picks. Deploy more, pay less with DigitalOcean, the simplest all-in-one cloud computing platform for developers. Scale and run cloud applications faster and more efficiently with effortless administration tools to robust compute, flexible configurations, networking services, real-time alerts, and rapid provisioning, while enjoying industry-leading price to performance with a flat pricing structure across all global data center regions at any usage volume. Spend more time building better web apps and less time worrying about managing infrastructure with DigitalOcean. Build your next app on DigitalOcean. Get started with a free $100 credit at do.co/jabber. AJ, do you have some things you want to shout out about?
Yeah, I do. So I am going to pick, again, IKEA. If you don't have an IKEA near you, you should move to somewhere where there is an IKEA. And if you don't have a home, you can buy one there. Jonathan Colton reference for those in the know. So one of the great things about IKEA furniture is that it is slightly better than terrible. Actually, it's a little bit more than slightly better than terrible. And what I mean by that is, like, you go buy a cheap, crappy bookshelf at your leading cheap, crappy discount store, and when you move, the thing disintegrates. Like, you pick it up and it just like falls apart. But when you buy a cheap, crappy bookshelf at IKEA, you can probably move like 3 or 4 times. And that includes, like if you have to move it from upstairs to downstairs, that's probably just as dangerous as a real move. And they don't disintegrate right away. You can move and even have some things on the shelves when you move them, which is a huge bonus, without them completely falling apart and turning into dust. And I think that is great because they're very inexpensive and compared to like a nice bookshelf, but they're very sturdy compared to a Walmart bookshelf, etc.
Gotcha. Yeah, my experience has been about the same. And I have 5 kids, so I don't get to have nice things. So yeah, I can attest to that. They'll stand up to quite a bit of abuse.
Yeah, I can attest to that as well. Pretty much all of my furniture right now is IKEA: bed, sofa, TV stands, tables. Everything is IKEA.
Are you a college kid or a divorced man?
Neither. Live-in girlfriend. So. But she tolerates my sometimes excessive frugality.
I was just joking with you because the IKEA song says that, and it's often true. It's a stereotype.
The IKEA song?
I am not familiar with the IKEA song. That sounds like another pick.
Yeah, it sounds like another pick to me.
Yes, I also picked the IKEA song, and I'll link to it.
By Jonathan Colton, huh?
Yes, that's correct.
Okay. I'm going to have to watch the YouTube video after this. I'm going to go ahead and take a minute for some picks. I think I've mentioned this on the show, or Joe has mentioned it on the show the last few times, but I'm still excited about it, so I'm going to mention it. And that's the Framework Summit. It's a conference coming up in October in Park City, Utah. I'm going to be speaking about Stimulus.js, which, if you're not familiar, is an extremely lightweight framework in JavaScript. And I've been playing around with that and enjoying it. So, yeah, I'm going to pick that. And I'm also going to pick, it was funny, on the Elixir Mix podcast, which I recorded about 2 hours ago with that panel, I kind of anti-picked the Amazon Prime Day because my wife has spent hundreds of dollars on Amazon Prime Day. But then she let me buy a set of golf clubs. So I'm actually going to anti-pick it, and I'm just going to pick it because I got golf clubs, and I'm a happy guy now. So I have some golf clubs. They're about 25 years old. They were my dad's, and he took me and my brother golfing a whole bunch when we were teenagers. And so I actually have 2 sets of golf clubs that are about that old. I think one of them's the ladies' set of clubs, which usually just means they're a little bit shorter. But anyway, it's just gotten to the point where, playing with those golf clubs, they make much nicer golf clubs for much cheaper now. And so I've been looking to upgrade, and I got basically a $380 set for about $150. So anyway, made me happy. So yeah. And then
you golf though?
I do golf.
Okay, just checking.
If you want to go sometime, I'm happy to go with you.
Well, thank you.
Are you good at golf, or are you just like a driving range type of guy? Because I'm a driving range type of guy. I have exactly 1 club, and I just go to the range.
No, I go play the holes. I'm not a great golfer. I think as far as great golfers go, I'm just that side of terrible. I don't know what my handicap is, but it's for me, and I guess I can just pick golf in general. But for me, it's nice for me to I'm outside, I'm away from the screen. I usually wind up going with somebody. My most frequent golfing partner is my father-in-law, but just get out of the house for a couple hours and just do something that's totally different from what I normally do. The only time that I enjoy golf a little bit less, I guess, is when the golf course is busy and I have people behind me. So I'm trying to finish out the hole so that they can tee off. But anyway, really enjoy it. So, if you're in Utah, I'm happy to go golfing with you. I have a couple sets of really old, terrible clubs that you can borrow. But yeah.
Nice. Yeah. If I get myself confident enough that I can actually play like 9 holes, I'll take you up on that.
Sounds good. Val, what are your picks?
Yeah. So my first pick is going to be my new ebook, Mastering Async Await. Mastering Async Await is all about getting you to understanding what the fundamentals of async await are and how it fits in the JavaScript ecosystem. So it will tell you kind of how async await works at a very low level, help walk you through building a promise library from scratch so you can understand both the macro and the micro of async await, and then also provide you a mental framework for determining whether, framework X, say React, Redux, Express, whether any of these frameworks work with async await. So check it out, asyncawait.net/JSJabber. It should be in the show notes. Let's see. Pick number 2. I've been using this NPM library, or NPM, I guess, command line tool called Serve recently. It's by Guillermo. It's like a Zeit project, and it's just a one-line tool for starting up a static server. It's been really great, and I think it's like a great example of like how good developer experience can be. It has like a couple of nice, neat tricks where it actually, when you start a server, it actually also copies the server URL to your clipboard, so you can just switch automatically back to Google Chrome, hit Control V, and you go to localhost / whatever port it starts on, which is pretty cool. So npmjs.com/package/serve. And pick number 3, I guess I'm going to go with something a little bit out of the blue, but I recently finished reading a book called Ultimate Skiing by Ron LeMaster. I've been skiing kind of on and off since I was like 10 or 12 years old. And this book kind of was like one of the first books out there that really made skiing click for me, and kind of how more advanced techniques like pole planting work. It's a great book for anyone who's like an INTJ or ENTJ on Myers-Briggs for actually learning how to ski, because it has things like force diagrams and kind of actual physics discussions on what happens when you're skiing or when you're pole planting. It really clicks for nerds like me. So check it out.
Sounds amazing.
It's a really fun book. Yeah. I guess you can look for Ultimate Skiing on Amazon, or I also have a bit.ly link, just bit.ly/ultimate-skiing. Check that out too.
Very cool. Well, thanks for coming, Val.
Oh, thanks for having me, Chuck. It's always great to be on your show.
Yeah, it's fun to have you along, and async await is one of those things that I had kept hearing about, and I used a couple of examples that I copied and pasted off the internet, and now I feel like I have a better idea of what it's doing and what I'm dealing with there. So I really appreciate you taking the time to make sure that we have the chance to talk about it and understand it.
Yeah, and thanks for having me on. It's been fun.
All right. Well, folks, we will wrap this one up, and we will catch you all next week.
Yep. Have a good one. Great being on the show. Thanks.
Adios.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.